of the hardest things in any scientific investigation is working out how you're actually going to prove or disprove your idea, your hypothesis. And so it's really important that when a methodology is developed for to test a scientific idea, that it suits what it's talking about. And so very quickly we got here the Marshall and Warren again, who pop up a few times. And of course, their methodology involved, first of all, um, doing a first-hand investigation of biopsies. And so they collected the biopsies in their lab and then studied them directly. And then, of course, Marshall experimenting on himself, which wouldn't at any stage pass any ethics committee at them these days, or indeed back then even. Now, of course, one of the problems there is that the reason Marshall did go off and do his little experiment on himself was that their peers were slow to accept the findings. As we've mentioned before, it was completely different to the idea. It was assumed and that microbes would never be able to exist in that harsh acidic environment. And so it's often very hard to get these paradigm shifts, these brand new ideas accepted. And of course, in their case, because they were quite good and they had all their data, eventually their peers had no choice but to accept the idea. Okay, and of course, when you're looking at stuff there, in this case here, you can sort of argue that a lot of what they did was qualitative data, but it was qualitative data backed up. Now, going back a very long time ago, is the idea of Eratosthenes and the Earth's circumference. Now, Eratosthenes back very, very long time ago, but one of the things there that people don't really understand is there is a cognitive bias in terms of the way we think of the world. We think that we as a species are so much smarter than the people 2,000 years ago. But people such as the ancient Greeks and Eratosthenes had a very good understanding. And what he did is he wanted to work out that the circumference of the Earth. It was assumed that it was accepted that the Earth was a sphere. And so what he did is he collected some second-hand data, because between the towns of Sienne and Alexandria was a very well-known trading route. And so there was very accurate data, very accurate measurements of the distance between them. And then what he did is that at midday, at Sienne and later on in Alexandria, he measured the angles of a post sitting in a well. And so this little small stick sitting in a well, at Sienne, there was no angle. Whereas in Alexandria, at the same time, there was a shadow. And so what we have here is that Eratosthenes collected that primary data. He was able to get the secondary data from the traders. And from there, an idea and a very close to the real value of the circumference of the world. As we said there, we know the Earth's a sphere. Ancient people knew it. The idea of the flat Earth is actually a very recent idea, which is something that a lot of people have trouble accepting. But in this case here, Eratosthenes, he had lots of little bits of data and he was able to put that together. And using mathematics, he got a very accurate measurement of the Earth's circumference, which is quite amazing considering there's no satellite technology, there's none of that there. And of course, his data was all qualitative. Now, one of the most well-known effects in physics is the Doppler effect. And of course, people associate that with sound, which is what we'll talk about in a second. But this is another idea in science that comes from one area and goes to another. So in this case here, Doppler was looking at spectra from stars. In particular, he was looking at binary stars, and he was able to observe the frequency of the light there as well. And so he had a really clever little technique where the stars were observed with a telescope that actually got the spectra, and he looked at those spectra coming in, and he noticed that depending on the way the binary stars were moving, in some ways the spectra changed depending on the relative motion of the stars. Or well, that's how he was able to explain it there. And so this idea of the Doppler effect is that light, or waves to be more precise, waves change, or their spectra change, their wavelength changes, their frequency can change depending on their relative motion. And of course, we now think about that in terms of sound. Most people will know, if a siren, an emergency vehicle is coming towards you, the pitch goes up, and then as it goes away, it goes down. And so it's an idea that's mainly applied to sound these days, but it's a property of all types of waves. And of course, as we said before, it's a really good example of how study in one area can lead to understanding in other areas. And so that's why when sometimes people talk about, well, why are we studying this? It's because it may lead to other things that we don't know of. And there's plenty of examples that we can look at later on that. Now, what we also have here, our last one for this section, is Priestley and his experiments with oxygen. So, as with a lot of these discoveries, there are debates about who discovered this, and Priestley is mostly credited with being the discoverer of oxygen. And so what he did is a first-hand investigation where he had mercuric oxide, so a chemical with a bit of mercury, a bit of oxygen in there. And what he did is he heated that up. And when that heated up and that reacted, there was a decomposition reaction which produced a gas. And that gas was what we now call oxygen. He sort of referred to as dephlogistated air, because there was this idea that substances burned because they had phlogiston in them. And what he did is he found that this gas, or this airs that he described, made candles burn brighter. He did do other little experiments where he tested its ability to sustain life. He is also the first person to really get quite giddy and dizzy over that as well. And of course, he did further this idea as well by looking and seeing there, that if mice were in a jar by themselves, they would eventually expire. If you put a plant in there and it was sunny, they'd survive. If it went dark again, they wouldn't. And so this here, it's qualitative. It's sort of, in terms of the mice, it's qualitative data. It's talking about, well, the effect, it either kills the mouse, it doesn't. I sniff the oxygen and I feel really high and giddy. And of course, there was a lot of chemical ideas going on at the time, and his idea was pretty much widely accepted.